So hello everyone, I am Bhavan Gayan and today I'll be conducting the session on Intro to ML first week. So is my voice audible to everyone? Is it clear? Yeah, okay, thank you. So maybe we should just wait for some time. We'll start at exactly 3 p.m. Okay, people are still joining, so I'll be waiting for a few minutes. Okay, let me start. Okay. Yeah, I think my screen is visible to everyone. So I am Baban Kain, and today I'll be presenting the previous year assignment questions for week 1, and also will try to attempt the practice questions too for assignment 1 in the for the previous year. I'll not be discussing the questions for this session for 24 this course code, because these assignments you have to solve that on your own, but the patterns are similar. So I think if you kind of attempt to solve the previous year ones, then you should be able to do this for this year as well. Okay. Yeah, good afternoon everyone. So okay, let me continue then. Okay, so okay, so okay, then we'll go to the first question. So which of the following is a supervised learning problem? So what is supervised learning problem? It is when we learn from the data, we have labeled data that this one is this, and we can learn from level that yeah, this, if the inputs are this, then outputs would be this, and from that we can generalize that in the test time, if data is something like this, then the output would be that. So here the first question is that grouping, like first option is that grouping related documents from an unannotated corpus. So unannotated means we do not have any labels. We are given suppose 100 documents, and there we are having articles like from sports, from politics, from entertainment, those from education, and we don't have any information that which documents belong to which category. So because we do not have any labels that which document belong to which category, during training or anything, we cannot train the models like yeah, this document belongs to this category, this that document belongs to that category, and model will learn. That will not happen here, because we do not have any information, because this corpus is unannotated, right? So in this case we cannot do any grouping based on the any supervision, because we do not have the information in the corpus. So in that case we can do some kind of clustering. Basically we will try to kind of group some similar documents, but again that thing which category one document belongs is not present in the data, so we cannot really apply supervised learning problem here. So this is actually unsupervised learning. So because of that, first option is it does not have any label, so that is why it is not really a supervised learning problem. I will go to the second option soon. Okay. So if you have any doubts, please feel free to ask in the comment box here, chat box. So you can write your queries there. Okay, I'll continue. So next one is that predicting credit approval based on the historical data. Here historical data means there are other users, other customers who had information like age, salary and stuff like that, and based on that we have a label that whether his or her credit application was approved or not. So this is basically is learning from the data, right? So we have something earlier, and when we are getting some new customer, we are trying to apply if he or she will get the loan application, okay, or credit card application. So basically what we are doing is that we are learning from previous experience, from the historical data. So that is why it is actually a supervised learning problem. So second option, if this is correct, this is a supervised learning problem. So next option is that predicting if a new image has cat or dog based on historical data of other images of cats and dogs. So where you are supplied the information about which image is cat and dog. So basically you have a data set and you have information that this image is cat, this image is dog, and you are given a new image and you have to predict that if the image is cat or dog. So this is also based on supervision, right? So you have labels and the model is learning from the labels that yeah, this image is cat, this image is dog. So this is also a supervised learning problem. Next one, fingerprint recognition of a particular person used in biometric attendance from the fingerprint data of various other people and that particular person. So basically suppose you consider you have an attendance system and there you have a fingerprint of many other people and you also have a fingerprint of that person, and you have to find that if that fingerprint belongs to that person. So again you have a fingerprint and you have a label that this fingerprint belongs to that person. So because of that you can portray this as a kind of a supervised learning problem. So you train the model to identify fingerprint, that this is the fingerprint, this is the person, that is the fingerprint, that is the person. So by that you can formulate this as a supervised learning problem. So this is also a correct option. So first question has 4 options and out of them 3 are correct. Only one that is not a supervised learning problem is that when you have unannotated corpus, that is when we do not have any labels. That is why we have to kind of group them without using any labels based on their features only. So we'll move to the next question. Anything in the chat? Okay. So this is we are actually doing questions from the previous year, run of the Introduction to ML course, which was in 2023. So this is the second question of assignment 1. Which of the following are classification problem? So classification means you have some kind of labels and you have to pick one of them. So it is kind of like option that you are can I play today, yes or no, can I go to the market, yes or no, or which color do I like, red or blue. So kind of if you are choosing between option, then it is a classification problem. So predict the runs a cricketer will score in a particular match. So this is kind of a tricky one. So cricketer can score anything between 0 runs to maybe 100 to 100 anything, right? This is kind of unbounded, first thing. Second thing is that this is also so when you are when you are predicting a number and that number is kind of like unbounded, generally it will be like a regression problem, not a classification. So basically when you were suppose there are two options here. Suppose here like a cricketer is scoring like 50 score and you predicted 45, like then it is quite similar, right? 45 50. But if you classify, right, if you classify and if you predict 45 and the player scores 50, then they are totally different, right? Because in classification 45 and 50 both are entirely different group, but in regression 45 and 50, because you are like regression is kind of based on the distance, so 45 and 50 you have only mistake is by the 5 runs. So in this case, yes, you can formulate this as a classification problem. How? One run is a score, one run is a option, 2 run is a option, like that. 500 run is the option, 1000 is the option. So this you can do, but again, will that be a good idea? No, because that will not create, that will not make a that will not make much sense, because if you use regression, then you can use that information that yes, even if you make a closer estimate that if he is scoring 50 and I am predicting 45, then it is good enough. But in classification, like you need to predict it exactly, otherwise it doesn't make sense. So in this case, it will be better to formulate this one as a kind of a regression problem rather than as a classification problem. But yeah, theoretically you can do as a classification, but that is not really a good idea. So first one is like this is wrong. So this is not a classification problem. Ideally, you should like formulate this as a regression problem. Yeah, so I am recording the video and I will upload it in a YouTube channel, and I will provide it in the the discussion forum or somewhere. Okay. Yeah. Yes. You will get the recordings. Okay. So second question. Let's continue. So which team will win a tournament? So suppose there are 8 teams in a tournament and you have to pick a option, like team 1, team 2, team 3, like so whenever you are picking between options, this is a classification problem, and whenever you are estimating something within a range, so that is a classification problem, that is a like regression problem. So that is the like general rule of thumb. So which team will win a tournament, that will be a classification, because you are choosing an option between some of the options. Then predict whether it will rain today. So again the options are yes or no. So it can rain today, it cannot. So again you should formulate this one as a classification problem. Then predict your mood tomorrow. So what can be the mood? Your moods? It can be like happy, sad, angry, maybe like there are very limited number of possibilities, right? Like in what can be your moods tomorrow. And if you are predicting that, so this should be a classification problem, because you are picking an option between some possibilities instead of like estimating here, estimating some range within, like estimating a number within some range. So in that case, this is also a classification problem. So in question 2 also, first one is not a classification, but remaining 3 are classification problem. So we'll move on to question 3. So this is about regression task. So question 3 is about regression task, and again we have multiple options and we have to select between them. Which of the following is a regression task? Predicting the monthly sales of a clothes store in rupees. So again, what can be a number here? It can be like 0, it can have like no sale, it can have 10 lakh, 20 lakh, 1 crore. So again, we have any number of choices, like not any number, it can be within fraction also, right? So here this can be regression. This is actually a regression problem, because there are many number of possible solutions, and we are asked to we are actually estimating a number within that range. So here the range is 0 to infinity. So we are predicting a number within that range. So that is a regression task. Then second option, predicting if a user would like to listen to a newly released song or not based on historical data. So yeah, one second. Yeah, so the question is classification problem same as supervised learning problem? So supervised learning has two branches, I can say. One is like classification, another one is regression. There are other branches also, but like these two are like both classification and regression, both comes under like supervised learning. Okay. But again, there are some methods like k-nearest neighbor, which we can do without supervised learning. So again, like is every classification problem is supervised learning? No, but here in this case you can see, if we are learning here from monthly sales of something, so in that case, that means like we have some kind of data what were sales the previous month or previous year. So we are basically learning from data. So in that case, yes, in this example, this is actually a kind of a supervised thing. But in many cases, like it might not be. So we had an example where we are kind of a we are kind of clustering something. So again, we cannot really say clustering as a kind of a classification problem, right? So generally, yes, both regression and classification can be said as a part of supervised learning. Okay, if we have labels for like which class what is the label of this image or this data. Okay. So moving on to the next option, predicting if a user would like to listen to a newly released song or not. So based on historical data. So here you have an person who listens to song, and you have information which songs he liked, which songs he or she disliked, and based on that, can you predict will he or she like a newly released song? So the options here are yes or no based on historical data. So this is a classification problem, not a regression, right? Yes or no. So this is not a regression task. Then predicting the confirmation probability in fraction of your train ticket whose current status is waiting list based on historical data. So you have information that on this state from here to here, from 3 AC or sleeper, and this many persons are going, and this was confirmed or this one was like waitlisted at the end. And based on that, you have to predict what is the probability. And here, like not that will you get confirmed or not. So if you get if you have to predict yes or no, like it will get confirmed or not, that means it is classification. But here you are predicting confirmation probability. So this is between 0 and 1, and it can be like 0.5, 0.55, 0.554, anything. So when you are picking a number within a range, it is a regression problem. So this is actually a regression task. I will quickly look through the comments here. Okay, some people also join. Okay. So next option is that predicting if a patient has diabetes or not based on historical medical records. Again, here you have a data that this is the patient and this is his like blood group and everything, like heart rate, like heartbeat rate and everything. And you have another level that if he or she has diabetes, and based on that you have to predict if a new patient has a diabetes. So options here are yes and no. So we have, when you are choosing between some options, this is a classification, not regression. So this is not a regression task. Final option is that predicting if a customer is satisfied or unsatisfied from product purchased from e-commerce website, and based on the reviews he or she wrote for the purchased product. So this is there are two options, one is satisfied, another one is unsatisfied. So when we are choosing between some options, this is a classification, not regression. So this is also not a correct option here. So in question 3 we got two correct options. Which of the following is a unsupervised learning? So yeah, so I'll again quickly look through the comments. Yes, on those multiple options can be selected in some questions. So in those questions where multiple options are correct, in those questions multiple options can be selected. So which of the following is a unsupervised learning task? Group audio files based on language of the speakers. So here you do not have any information what, so suppose you have audio of 100 people and you have no information which one is which language. Suppose first audio is Bengali, second audio is Hindi, third audio is like English, but you do not have any information. Maybe they are, maybe they are not. So there are audio, but you don't know which one is which language. So when you are grouping based on that, you can do only one thing. You can group them based on their similarity. If two audios are similar, maybe there are one audio English, one audio is another audio is also English. You can group them together. But again, you cannot know for sure that which language is which. So maybe one person can listen, then say, yeah, this is English, that is fine. So whenever you are working without labels, this is unsupervised learning task. So this is a correct option. Second, group applicants to university based on their nationality. So again, here also some people apply to an university and they do not have a kind of a label that in the application they do not have any label that I have applied for this, I am from this kind of a, I am from this place or that place. So whenever you are grouping into something and you do not have any labels for them, you are doing based on maybe some other information maybe some information suppose if two people are from India, maybe their resume might look similar, or their educational background might look similar. So based on that, based on similarity between them without having any labels, you are grouping something. So this is also an unsupervised learning task. If we had any labels that based on this is Indian, so based on that predict if someone is Indian, that is supervised. But in this case we have many people from many countries, suppose India, Bangladesh, China, and USA, France, everyone, and we have applications from them, and we do have their application but not the country from where they belong. So we want to group them but without knowing their actual levels, and we do not have any training data as well to kind of predict that. So whenever we are grouping based on unlabeled data, that is kind of that is a unsupervised learning task. Then predict a student performance in final exam. So how can we predict student performance? Based on historical data, right? So how the student have performed earlier, how are other students performing in this final exam, or how is the preparation? So based on kind of labels, right? So we have labels that this student done like got this marks in the previous exam, that mark in the previous to that exam. So we are having label data, and based on that we are predicting some number. So that is a supervised task, not unsupervised. So this is a wrong option, because here the prediction will be based on historical data. Then predict the trajectory of a meteorite. So meteorite is kind of a object that falls from like a celestial object, which like falls into earth. So how can you predict a trajectory? We can kind of see that what are the trajectories of other meteorite, and based on that we can estimate that this will be the trajectory of this meteorite. So here also we have some information, we have some label that label about trajectory of a meteorite, earlier meteorites. So this is also based on the historical data. So that is why, and this is also is not a unsupervised learning task. This is also a supervised learning task. So I'll wait for 1 minute, then we'll begin again. Okay, so multiple option thing, I hope my screen is visible. So you can see here which of the, so in assignment 1, suppose first and second options are correct, you can choose from here, like first and second option. I don't know which of the options are correct. So suppose these two are correct, you can choose like this, or if first and third are correct, you can choose like this. Okay, but in this case of here, only one option is correct, so you can choose only one option here. Here multiple options can be correct, so you can choose multiple. So like if it is round, then only one option is possible. If it is like a square, then multiple can be selected. Okay. Then we will move on to next question. Which of the following is a categorical feature? So we, sure, go ahead. Okay. No. So classifying a species based on, suppose you have a 10 species, okay, and you have trained the model to classify that, right? So whenever you are training the model, you have data, right? So I'm saying that you are trying to predict a species name from the image, right? So before that, like before predicting, you have some information, right? This species looks like that, so you have some kind of data that this image means that species, that image means this species, right? So whenever you are dealing with label data, that you have a label that this one belongs to this image belongs to that species, so that is that comes under supervised learning. And whenever, like suppose you have many species, but you don't have any information, any training data that which one is which species, but you want to group suppose cats together, but you don't really have any information that which are cats, but you want to put images of the cats which are looking like cats together. So in that case, that will be unsupervised. But in this case, you are basically predicting based on historical data. Yeah, this species looks like this, and this species looks like this. So in that case, you are learning from the data only, labels from you are learning from the labels which is present in the data. So that comes under supervised learning. Okay, so suppose you have 20 images, okay, and you know you kind of identify. Suppose there are 5 images of cat, okay. You don't. It is not written that those are cat. Suppose there are 5 images of cat. So if you do that based on similarity, you can identify this. Yes, these 5 images are similar, but can you tell that what species are they? Suppose there is something some species which is very uncommon, not cats suppose, and you got 5 images of them, okay, and you can say that yeah, these 5 images are looking similar, right? So you can group them, right? But can you tell them that which species is that? No. So yeah, so because they are saying that you have to identify the species, so that is that you have to kind of assume that you have some kind of label which species is which. Yeah. So I'll move on to the next question. Which one of the following is a categorical feature? So number of rooms in a hotel. So this one can be like number of rooms in a hotel can be anything, right? One hotel can have 500 600 like rooms. So again, if you predict 50 and actual room is 60, then it is near correct. But if we portray this, if you kind of keep this as a classification problem, like if you consider this as a categorical feature, that means like 55 and 60 are completely different. But if you consider this as a kind of a like so yeah, if you consider this as a kind of a not a categorical feature, just a number, so in that case like this actually makes more sense. So that is why like yeah, number of rooms in a hostel can be a category. Suppose 1 room, 2 room, 3 room, so each of the number can be a category, but that will not be a good approach. But if we keep this as a just a field with number, and it can be anything like 1 to 500 600, so that will be a better approach. So this is not really a categorical feature. Gender of a person, yes, you can choose between very few options, male, female, like transgender, and like so basically only you have very limited options there, and you have to choose between that. So this is actually a categorical feature. Then your weekly expenditure in rupees, so this can be any amount, any number, so this is not really a category, right? So this is not a categorical feature. Ethnicity of a person, again it can be like Indian, African, like very limited choices, and you have to choose between this, so you have to choose some options from the category. So this is the categorical feature. Area in square centimeter of your laptop screen. So laptop screen, it can be like any size, maybe 15 inches, 20 inches, anything. So again this is a number, and you have to choose between 0 to any number. So your laptop screen can be any size. So this is also is not a categorical feature. The number of the color of curtains in your room. So color of curtains is also, it can be like blue, green, yellow, red. So we have limited choice and you can choose. So you are basically choose, you have a there's a category of options, and we are choosing between them. So this is also a categorical feature. Number of legs of an animal. So animal can have 2 legs, 8 legs also. Some animals have. Some insects have much more than that leg. So this can be any number. So this is also is not a categorical feature. Minimum RAM requirement of a system to play games like FIFA. So again, RAM requirement can be anything, 2 GB, 4 GB, 8 GB, like this is unbounded, and this can be like any option. This is not really a category. This is like we are choosing a number between some bound. So this is also is not a categorical feature. So this is the question 5. Then we will go to question 6. So which of the following is a RL task, reinforcement learning task? So learning to drive a cycle. So can you learn to ride a cycle using RL? So consider this. You have a robot, and he is kind of driving the cycle, and he falls down, he gets negative reward. He kind of he is able to reach the goal, he gets positive reward. So by this, can he learn to drive a cycle? Yes. So this is actually a reinforcement learning task, because by interacting with the environment, he or she can learn to ride a bicycle. Then learning to predict stock price. Stock price, how can you predict? We have to we have to understand what were the prices earlier and how it went up, how the price went up, how the price went down based on historical data. So it is not really done by someone that I will invest some money, and if I lose, then I'll understand that this is a bad idea, and if I get profit, then I'll understand that this is a good idea. By that I will learn. That is also possible, but is that really a good approach? Not really, because you might make much more loss by using that approach. So this is not really an ideal reinforcement learning task. So it makes sense to do it based on the historical data. Then learning to play chess. Can you learn to play chess based on playing with computer or playing with some environment, whatever? Yes. So again, this is also a reinforcement learning task, because it can be learned by interacting with the environment. Then learning to predict spam levels for emails. So again, this makes more sense if you do this based on the previous data, that this email is spam, this email is not spam. That means that new email that has arrived now is probably a spam. So it makes more sense that if you do this based on historical data rather than learning with the environment. Maybe if you try to do this based on reinforcement learning, what will happen is that suppose you build an agent and you get positive rewards if he is correct and negative reward if he is incorrect, if the model is incorrect. So what will happen is that initially it will not be able to classify, right, if something is spam or not. And what will happen is that many customers will be very angry that this is not able to classify correctly. So again, if you apply reinforcement learning here, technically it is possible, but it is not really a good idea. So only two of the options are correct here. Yes, for number of legs we have limited choices. We can technically say formulate it as a categorical feature, but again, suppose you have a in categorical feature, suppose you have a blue and red, assume, then you can consider blue. Why they are categorical? Because blue and red are completely different from each other, right? But in legs, suppose 2 legs is much more similar to 4 legs compared to 2 legs is similar to 8 legs, right? And 4 legs is closer to 8 legs. 4 legs is closer to 6 legs than it is to 8 legs. So whenever you want to keep something, keep the relationship between them. So suppose if you convert them to category, legs into category, 2 leg will be entirely different category, 8 leg will be entirely different category, and 4 leg will be entirely different category. The relationship between them, that only 2 leg is more, 4 leg is just 2 leg more from 2 leg, that relationship will be lost if you convert them to category. So yes, technically you can formulate this as a categorical feature, but then the relationship between them, relationship between 2-legged animals and 4-legged animals will be lost, because both of them, they will go to entirely different category. So I hope that makes sense. In this case, we have many different colors, and even that that can be a categorical data. Okay, in that case we have many different colors. Okay, we have many different colors. Okay, and even that, no. So suppose you have even if you have 50 colors or 100 colors, but they are entirely different from each other, right? So here in case of legs you can just assign a number 1, 2, 3, 4, anything, and their relationship is preserved. But if you in case of color, green is different from red, right? So you cannot suppose in case of like in case of legs, you are trying to predict the number of legs of some animal, and actual number is 8 and you are predicting 6, then that means it is partially correct. But in case of color, if the actual color is red and you are predicting green, it is you cannot say it is partially correct or nearly correct or anything. This is completely wrong, right? So in case of categorical data, you can see that whenever you are converting to category, if you pick the exact category, then it is correct. Otherwise, that is like that does not make sense. Here also, like in this case, if you convert the colors, suppose you have kind of a 100 colors, then how can you not without categorical data, how can you represent them? One for green, or 2 for red, 3 for black, that is possible. But how 1 or 2 are related, like how red is related to blue and blue is related to green, so they are not really related. But if we are not converting them to category, then and if we are assigning them the numbers, that means like 1 is closer to 2, 2 is closer to 3, right? So that is why like it make more sense to convert them to category. I hope it is a little bit clear now. So again, like in many cases here, you can technically formulate them as any kind of data, legs into a kind of a continuous feature, like just the numbers. But will that be a good idea? Not really. So moving on to the next question. Let x and y be a uniformly distributed random variable over the interval 0 to 4 and 0 to 6 respectively. So range of x is 0 to 4 and range of y is like 0 to 6. If x and y are independent events, then compute the probability p of max of x, y greater than 3. So we have to find what is the probability that maximum of x and y will be greater than 3. So at first let's find when the maximum of x, y will be greater than 3, when x is greater than 3 or y is greater than 3. So what is the probability of x greater than 3? So we have interval 0 to 4, so and we want greater than 3. So 0 to 1, 1 to 2, like so this is actually continuous, okay? So it can be like 0 0.5, 0 0.005, everything like that also. So what is the probability of greater than 3 here out of 0 to 4? The probability is 1.1 by 4, okay? And for p of y greater than 3, what is the probability? It is like 0 by 6. So the range is 0 to 6 and we have to find where y is greater than 3. So in that case, the range, the answer is like 3 by 6. So 3 by 6, if we simplify, it is 1 by 2. So probability of x greater than 3 is 1 by 4. Probability of y greater than 3 is 1 by 2. So then how to calculate their probability of those combined? They are, remember, they are independent event, right? So what can I do is that we can take the sum of them and then we can kind of subtract the intersection between them. So suppose in some cases it is possible that x is also greater than 3, y is also greater than 3. So what is the probability of that? We will just subtract. So basically consider this as a Venn diagram. So you have x here, you have kind of y here, x greater than 3, y greater than 3, and you have to kind of subtract this one because you are calculating like Venn diagrams from both the sides, because this intersection is coming twice in these two, okay? So p of x greater than 3 is 1 by 4, p of y greater than 3 is 1 by 2, as we have seen from here. Then it is mentioned yeah. So it is mentioned that this is independent event, and in case of independent event we can calculate the intersection between them by just multiplying them. So 1 by 4 into 1 by 2. So if we sum them, this is 3 by 4 and this is minus 1 by 8. Okay, and if we calculate this, the result comes out to be 5 by 8. So this is the answer of this question. Okay, we'll move on to the next question in a bit. Okay, so the question is find the mean of 0, 1 loss for the given prediction. So 0, 1 loss means if the answer is correct, then loss is 0, and if the answer is incorrect, then loss is 1. So as simple as that. So here the correct one is cat and the model predicted one is cat. So this is correct, so loss is 0. Cat dog, this is incorrect, loss is 1. Dog panda, it is incorrect, so loss is 1. Panda panda, so this is again correct, so loss is 0. Rat and dog, this is incorrect, so loss is 1. Rat and rat, this is correct, so answer is 0. So what are the sum of them? 1 1 1, so total loss is 3. And how many examples are there? Total 6. So 3 by 6, loss is 1 by 2. So and this is like very simple one. This 1 by 2 is the answer of this question. Okay, moving on to the next question. Which of the following statements are true? Check all that apply. So multiple statements can be true, and you have to select multiple options if it is applicable. So a model with more parameters is more prone to overfitting and typically has large variance. So basically, whenever you are training a model, and if the model has higher parameters, large number of parameters, then that means the model is more capable to do everything like generalize to kind of also memorize the data from the training set. So what can happen when you have very large model, when you have large model with very large parameters, it can learn to memorize all the data. So suppose you have very low amount of data and very large model, what it can do is that it can learn to map each of the examples exactly. So it kind of like learn, as the model parameter is huge, it is kind of like very capable, and because of that it can store the mapping between every input and output in the training data. So what will happen is that if it is storing every mapping between input and output data from the training data and including noise and outlier from the training data, what will happen is that it will be able to perform well only on the training data, not on the other data. So that is really what we call overfitting, because like model is able to memorize whatever is there in the training data but is unable to find a pattern, generalize. So suppose if you take an example, you have some data about will it rain today or not, and you have some records like temperature, humidity, those stuff, and if the model is very huge, then it will learn that on this day temperature was 35, humidity was 85, so 35 temperature and 85 humidity means rain, and without understanding like any pattern that if this is high then chances are higher, without identifying any pattern, the model can simply memorize. And what will happen in those cases, suppose you are giving 34 and 76, even though they are very similar, but still model will not be able to do it correctly because it is kind of overfitting. So because of that, like this statement is true. I'll go to the second option soon. Okay. So if a learning algorithm is suffering from high bias, only adding more training example may not improve the test error significantly. So again, here also high bias actually indicates that model is very simple. Okay, and model is simple means like it is not able to learn. It is not really it is not able to capture the patterns in the data, training data. Okay, and if we add any more training example, so what will happen is that model capacity is not increased. Okay, but we are just taking more training example, but as the model capacity is not increased, it will not really help the model because model is not really sufficient to capture the capture the patterns in the data, right? So if we add more data, the problem will be more. So we have more patterns in the data, but model will not be able to capture it simply because our model is not that complex, model is not that large. Next one, when debugging learning algorithms, it is useful to plot a learning curve to understand if there is high bias or high variance. Okay, so whenever you are training a model, you can do one thing. You can you can plot a graph with training loss and validation loss, and if there is like a very large gap, so if suppose training loss is like a 50 and validation loss is 10, that means like this is actually high variance. Okay, and when there are like training loss is 100 and validation loss is also like not 100 but say suppose 95. So yeah, the gap is small, but the error is actually very large. So in that case, it is like high bias. Why? Because in this case, you can see like in the training data loss is high and in the validation data loss is low. So that is why like there is large difference, and that means that the data is very that data is like of varying quality. So training data is something, and test data is like is kind of varying like that, like not really very similar to the data set. So that indicates that there are model is able to learn training data, but it is not really generalizing on validation data. So that indicates that model is having high variance. But when you are loss itself is very large for both training and testing, for training and validation, that means like model is unable to generalize, okay, on the data set. So that means like it indicates high bias. So all the three here are the correct option. If a neural network has much lower training error than test error, then adding more layers will help bring the test error down because we can fit the test set better. So again here the observation is that training error is less and test error is high, and if we add more layer, then what will happen? It will be it will have much more added capacity, and then it will be able to fit on training data set in much better way. But will that affect the test error? No, because here the thing is that training data it is overfitting on training data, and it is not really generalizing. That is why it is test error is very high. Okay, so if you add more layers, what will happen is it will overfit even more. Okay, and that will actually worsen the test error. So if the error before adding layer is 50, maybe after overfitting it can go to 60, 70, because the cause was overfitting, and after adding more layer we are actually increasing like effect of the cause in the overfitting problem. Okay, so this is the question 9. So question 10, this is actually covered in the error and bias lecture, bias and variance lecture. So here which of the following answer is correct, error and bias and variance. So bias one is like expectation of f prime x minus fx, so this one is correct. This one is also similar option, so these two might be correct. This one is not correct, because you can see in the lecture also that here it is actually square, but if we consider bias, there is no square term. Okay, bias square is this, but bias is this. Okay, so only option here is A and B that are possible. Second one is that variance. So here expectation of f prime x minus f of x, f prime x, and then we are taking whole square, and then we are taking expectation of that. So this is the correct option, not this one. So if you follow the lecture bias and variance, I think this one is covered. So I'll move on to the next. So this from week 1 assignment, these were the 10 questions that were discussed. Then I will move on to the question 11. So this is actually from the practice assignment of week 1 from the previous session. So which of the following tasks can be solved using clustering? So predicting the amount of rainfall based on various cues. So can we do this based on clustering? So basically we have some information that we have some information about temperature, and we have some information that humidity is that, and things like that. Can we really predict any rainfall based on that if we do not have any label data? That we cannot without any label data, that if this is the temperature, rainfall is more likely. Not really. Even if we do cluster them, suppose same temperature, same humidity, we are clustering them, they come together, but can we obtain any conclusion that if data from this cluster will rain? No. So this really can't be solved using clustering. Second one is that detecting fraudulent credit card transactions. So that we can do. So basically what can we do is that we have some data of people, and we have information that this is fraudulent, this is not fraudulent, and if we cluster them, so suppose these are the fraudulent data, there are some fraud, and these are not fraud, and if we get a new transaction which is not present, and we can kind of create a class that does it belong to this category or this category. If it is belonging to this category, then yes, this is fraud, otherwise this is not. Training a robot to solve a match. So this is actually a reinforcement learning problem. So a robot can learn to solve a maze by interacting using environment, and we cannot really apply clustering here. So there is not really any data to cluster the movements or anything. So this is not really cannot be solved using clustering. So next question. So Pavlov's experiment is a classic experiment conducted by Russian psychologist Ivan Pavlov. He experiments on dogs shown in the image. So basically what they do is that they have a dog, and whenever they observe that whenever dog sees or smells food, it produces saliva. Okay, and so the idea is that whenever the dog is observing food, it is actually stimulating dog's response that I'll be getting some food. So that is why it is secreting saliva. Then what they are doing is that they are ringing a bell every time. So before giving food, they are actually giving just ringing a bell, and what happens is that the dog learns that if I am hearing a bell, it is time for my food. Okay, so that is the meaning of conditioning here. And after conditioning, that what happens is that even if you don't give food, but if you ring the bell, the dog assumes that it is my time to eat, and it is even if you don't see the food, even if the dog is not seeing the food, it is like its response is it is producing saliva. Okay, so this is the observation. Then we have multiple questions on that. So which of the options are correct? In this experiment, the dog acts as an adult agent. Correct, because you can see here the options are that here dog is the agent and environment is the giving him food, and so his options are like producing saliva or not, and the environment is giving him food based on he is interacting with the environment. So in this case the dog is acting as a adult agent. So this is one is correct. So in this experiment, the dog learns in a supervised setting. Is this correct? Not really. So we don't have any data that if you produce saliva you will get food. If you don't produce saliva you don't get any food. The experiment is not like that. Okay. So this is not really a supervised setting. Then comparing to the experiment of adult theory, the various states are. So in reinforcement learning lecture you have seen that there can be states, and in this case what are the states? Presence of just the bell. So only ringing the bell, but not the we are not giving the food, we are just giving the food, and we are giving both food and bell. So these three are the states, and the dog is producing saliva based on that. So what happened is that a dog used to produce saliva only when he was giving food, but when he was giving both food and bell, he learned that if bell is ringing then I will get food. But after some time, even if you give the bell but not the food, it is kind of producing saliva. So that is the observation here. So these two options are correct here. Okay, then we have a probability question we will discuss soon. Okay. So there are n bins. So bin means you can consider bucket, and each kth bin. So first bin contains k minus 1. So 0 blue balls and n minus k red balls. And what you do is that you pick any bin at a random and remove 2 balls at random without replacement. Okay. So basically you have n bins, and your first bin has suppose 0 blue balls, second one has 1, 2, 3 like that, and last one has n minus k, and opposite for red balls. Okay, this one has one blue ball and last one has 1 red ball. Second one has 2 blue ball, third one has 2 blue ball, and third from the end has 2 blue balls like that. Okay. So we have to calculate two things. One, the second ball is red, and then the second ball is red given the first one is red. So at first we will focus on the first one. The second ball is red. So what are the things that are given? So we have n balls and we have n bins, and we are picking at random. So what are the chances of any bin to be picked? So n bins, and we are picking ones. So the probability of picking some bin is 1 by n. So I think this is clear. Then how many balls each bin contain? K minus 1 blue balls plus n minus k red balls. So how many balls total? N minus 1 balls. So we have total n minus 1 balls. Okay, for every bin. Then what is happening is that in every bin we have n minus 1 balls. In first one we have no blue balls, but n minus 1 red balls. In second one we have 1 blue balls and n minus k minus 1 n minus 1 minus 2 like blue balls, n minus 2 blue balls like that. Okay, so like this. So here we have one blue, here we have one red, two blue, two red. So this is kind of a symmetry. Okay, so even intuitively we can find that like this is as we are picking randomly, and each of them has kind of a symmetric nature. So one blue, two blue, three blue here, one blue, one red, three, two red, three red there, and like that. So in that case, like this kind of forms a symmetry, and we can intuitively say that yeah, the probability is half, because both like red and blue are equally likely. But how to do it mathematically will show. So what is the probability of C2 being red? C2 means like we are picking two balls, and probability of second ball being red. So n minus k, which means like probability of first ball chosen was suppose a red. Okay. So here n minus 1 means like total number of balls in that bin, and n minus k is the probability of choosing red ball in the first try. Okay. Suppose we have chosen red ball here, then we are choosing the second time. Then what will happen? Number of red balls will decrease by 1, so n minus k minus 1, and total number of balls will also increase by 1, so n by 2. So this is the first choice, and suppose what is the chance of first choice? In first choice picking red, and here what is the chance of what is the probability of what is the chance of picking red ball in second attempt? Second attempt, given we have picked a red in the first attempt. But it is also possible that we can pick blue ball in the first attempt, right? So what are the chances of picking the blue ball? K minus 1. See here, each bin contains k minus 1 blue balls. So whatever the bin is, the chances of picking a blue ball in the first chance is k minus 1 out of total n minus 1 balls. And if we pick blue balls here, that means like number of red balls remaining the same. So here in the second attempt we have one reduced number of ball, but number of we can say number of total number of red balls remain the same. So this is the equation, and if we simplify, so denominator is common, and if we simplify this, this will come as n minus k by n minus 1. So this is for only one bin. We have to find it over n bins, right? So what can we do? Summation of 1 by n is we are taking the average, okay, and summation over k equal to 1 to n minus k by n minus 1. Okay. Then this is n minus 1 is not dependent upon k. Okay, so we can move it here, 1 by n into n minus 1. Then what will happen is that so so we have to find k equal to 1 to n, summation of k equal to 1 to n of n minus k. And how to do that? Suppose let's focus on this part, okay, n. Summation of k equal to 1 to n for, and we are summing over n. So how many times n will appear? K times, right? So n times k will go from 1 to n, so total n times. So n times we are summing n. So what does that mean? N square, right? N plus n plus n times. So that means n square. Then for minus we will take it here. So minus we give it here. Then summation of k from 1 to n. So what will happen is that for first one it is 1, for second one 1 plus 2 plus 3 plus up to n, right? So how does it mean? 1 plus 2 plus 3 up to n, it means like n into n plus 1 by 2. Another formula, right? So summation of some number up to n is n into n plus 1 by 2. Okay, so we have got this. Then what can I do here is that let's simplify this. So if we multiply subtract this, okay, So this will be like a 2n minus 2, right? So we put the 2 here, this is 2n minus 2, and this is like, if we multiply here, n square plus n, right? N into n square, n into 1 n. So then we have a minus sign here, so it will be minus n square, and here it will be minus n. So this will be the simplified one, 2n square minus n square minus n. Okay. So if we again simplify this, so n square, 2n square minus n square is n square, and minus n is there. So if we simplify this again, n into n square, and n into 1 1. So n square minus n square minus n. If we cut this, the value is 1 by 2. So doesn't matter what is the value in n. If it is if we are considering like this, like if the first bin contains if k bin contains k minus 1 blue balls and n minus k red balls, always the probability is 1 by 2. Doesn't matter what are the other kind of what is the number of n. I hope this is clear. So I'll move on to second part of the same question in a few seconds. Okay. So again, this is the same question, but we have to find that second ball is red given the first one is red. So we have already found that second ball is red. We have to calculate the probability that first ball is also red. So this is like a joint probability that P of C2 is red, second choice is red, and also C1 is also red, first choice is also red. How to find that? N minus k, n minus 1. So what is this? This is the chances of picking the red ball in the first chance, and this is chances of picking the red ball at the second chance, given we have already picked first ball in the first chance. Because if we are picking, there are n minus k balls, k red balls out of n minus 1 balls total, and if we have already picked one red ball in the first chance, that means we have n minus k minus 1, because we already picked one balls remaining out of n minus 1 minus 1, that is n minus 2 balls. Okay. So this is for only one bin. Okay. This is the formula. So for first bin, we can replace with k equal to 1. For second bin, we can replace k equal to 2, like that. So this is only for one bin. What will happen if we take summation over all the bins? So this is the calculation. So I'll try to show you. So what are you doing is that we are taking average over all the bins. Okay. We are calculating from k equal to 1 to n. Okay, and then n minus 1, n minus 2, because this is the denominator here. Okay, we are taking summation over this n minus 1, n over 2, and then we are taking the here. So here n into n, what is it? N square. Okay, n square is there. N into minus k, what is this? Minus nk. So this is also there. N into minus 1, this is minus 1 also there. Minus k into n, minus nk also there. Minus k, so this is plus k also there, and minus k and minus 1, this is plus k, this is there. Okay. So what can you say is that there are two nks, one nk here, one nk here. So we can combine them, and we are basically here also, this one is not dependent upon k, so we are just taking it here outside. Okay. So what can you do is that in n square, we are taking n square, and there are two nks, we are combining them, so it is 2nk plus k square. Then we are adding the remaining two, which is plus k and minus n. Okay, here. Then this one is what formula? A minus b whole square formula. So we can write it as n minus k whole square, right? So basically we are writing it as that n minus k whole square plus k minus n. So this whole thing, it has a short form. So this is not really a scope of the assignment, but like you can find it online, that if we take a summation over k equal to 1 to n from n minus k square plus k minus n, this translates to n minus 2 n minus 1 into n. Okay. So here also we have n into n minus 1 n minus 2. So we can like kind of cut this, and ultimately what will remain is 1 by 3. So basically the short form or like simplified form of this whole summation is that n minus 2 n minus 1 into n by 3. So if we cut the n minus 2 n minus 1 n here and here, then only option we are remained with is 1 by 3. Okay. So this is the probability of C2 is red and also C1 equal to red. Okay. So this is the probability. But what we need to find? We need to find that C2 is red given C1 is red. So how to find that? We have already know that what is the probability of C1 equal to red, right? In the previous we have find that C1 equal to red, we have found that it is 1 by 2, right? So we will just divide it with it. So 1 by 3 by 1 by 2, it is 2 will go up, so the probability is 2 by 3. So the answer for two part of the question is, first part is that half 1 by 2, and in second part like if what is the probability of C1 red given C2 red, in that case the answer is 2 by 3. Okay. Next question. Okay, we have a medical company and it kind of tests for a medical disorder, and false negative rate is very small. And if you have a disorder, suppose you have a disorder, then probability that it will return positive is 0.999, and 0.1001 is the chance that even if you have some disease, it will not, it will say you don't have, like even if you have a disease, it will say that you don't have disease. So that chance is 0.001. Okay. And false positive rate is also small. False positive rate is 0.005. So if you don't have a disease, it will say you have a disease with probability 0.005. And out of 100 like out of total population, only 2% of the population have this disorder. So suppose a person is taking the test and the result is that you have that disease, that disorder. Okay. What is the probability that that person actually has that disorder? Because you know here the tests are not exactly 100% reliable. You have false positive, you have false negative. So yeah, if it is coming result is coming positive, you 100% cannot say that you have the disease. So what is the probability of that? You have to find out. So I'll go to the solution here. Let T be the probability of test being positive and D be the probability of person having the disorder. So like these are just some variables we are taking. Then what is given in the data? Probability of T being T, given T. So if a person is having a disorder, and what is the probability of getting the positive test result? So this is that a test returns positive result is 0.99 if you have the disorder, right? So this one we got 0.999. And if we don't have a disorder, what is the chance of it being positive? So false positive rate is 0.005. Okay, I think these two are clear. And what is the chance that some person will have a disorder? This is 2%. So this is 0.02. Okay, 0.02. And what is the chance that a person will not have the disorder? 1 minus this one, 0.98. So there are like a 0.2 chance that you will have the disease, 0.99 chance without you will not have the disease if you are like without having any information about test or anything. If you have the disease, there are 99.9% chance that you will get a positive result, and if there is if you don't have the disease, there are like still 0.5% chance that you will get a positive result. So you have to calculate that you have the information that someone got to the lab and like his test was positive. Yes, you have the disease. You have to find the probability that the person actually has the disease. So how can we find that? So we have to find a person actually has the disease given the test is positive. So how can we do this? We can apply Bayes rule here. P of A given B is equal to P of B given A by P of A by P of B, right? So here just replace A with D and T with B, and this is the same formula, right? So again, like this is the same formula. P of T of D, P of T given D, we have P of D, we also have. What we don't have? We don't have P of T. So P of T means what is the like a probability of test, okay? So what is the probability of test being positive, right? So how can we find that? What is the probability of test being positive if the person actually has the disease, and what is the probability the person has the disease, right? Plus what is the probability of coming test positive if person doesn't have the disease multiplied by what is the probability person doesn't have the disease, right? So this is the like kind of total probability of test being positive, and this is the like just on the spot that what is the probability that the test being positive if it is the person actually has the disease. So if we substitute the numbers here, so P of T given D we already have got from the data 0.999, and P of D we have 0.02. So 0.999 and 0.02. So same for here also, we can just copy this one. What is the probability of actually getting positive if he or she doesn't have the disease? It is 0.005, right? So we are just taking it here, and what is the probability of not having the disease? This is 0.98. So if we kind of calculate this, this turns out to be 0.803. So this is the answer of the question. So if you have any doubts, please feel free to ask any questions. In any of the questions or anything related to the course. Okay, so we'll go to the final questions for today. So this is this was also came in the assignment, practice assignment of week 1. So in an experiment, in coins are tossed, and which they are not really fair coin. In fair coin, what happens is that head has 0.5 probability, tail has 0.5 probability. But in this case, that is not really the case. We have head probability of 0.4 and tail probability of 0.6. Okay, and we are tossing 15 coins, and if we suppose there are heads, suppose there are 10 heads in the first round, then what we'll do, we'll again toss 10 more coins in the second round. Okay, so the question is that we don't care how many heads are there in the first attempt, but how many heads are there in the second round. Okay, and what is the probability of having 5 heads in the second round. Doesn't matter how many of them, how many heads were there or tails were there in the second round, in the first round. So what can happen is that so if we don't have any head in the first round, what will happen? We won't even go to second round, right? So even though they are totally independent, but occurrence of second round and how many tosses will occur is dependent upon the first round, right? So if we have 10 heads in the first round, then we'll have 10 tosses in the second round. If we have 5 heads in the first round, we'll have 5 tosses in the second round, like that. So we can simplify this. Okay, we can combine round 2 with round 1. How can we do this? Suppose okay. Okay, so can you give the which lecture we are talking about? So we have this one, regression and classification. So if you are talking about okay, wait a minute. Yeah, week 1. So I think we have some transcript somewhere. Okay, so yeah, you can see here in this case, suppose we are calculating a loss based on y, which is kind of we can say actual result, and fx, which is the result provided by the model, right? And how to calculate the error? Y minus fx whole square. This is basically mean squared error loss. Okay, and in EP we are taking expectation over this. Okay, so basically what we are doing is that so in this case we can expectation, we can formulate this over kind of because we are doing sampling based training, because we are not using the data. We are trying to estimate the loss using sample from the data set. We are in this case what is the joint probability of x and y. So probability of y given x and probability of x, right? Then if we calculate the EPE, okay, sorry, just yeah. Okay, so okay, so EPE yeah. So you can see here that at first we are taking expectation over x, because you have two probabilities here, right? Y given x and x. So we are basically taking expectation over both of these, expectation over x and expectation over y given x. So these two are the probabilities, and then what we are calculating, so y minus f of x whole square, this is kind of the loss here, and given x, right? So basically what will happen is that, so this one is for regression. So just wait a minute. Okay, so yeah, it is little bit difficult to like configure here. So is it okay if I provide a document about this in the discussion forum? I think that will be more beneficial. Yeah, okay. So yeah, in this one EP I will prepare a document and I'll share in the discussion forum, and that will be I think better. Yeah, I'll go to the problem. Okay. Okay, so we can formulate this as a kind of a we can combine this problem. So I'll just quickly discuss the problem again. So we have 15 coins and we will toss a coin 15 times, and if there is head in the first round, we'll toss that again in the second round, and we have to find the probability that 5 heads will occur in the second round. So let's combine round 2 with round 1. So what will happen is that suppose we have 15 tosses and we are tossing one at the 16th time. Okay, so is it equivalent to suppose in the fourth toss we have head? So doesn't matter if I just take the next toss or if we take the toss at the end, right? So we can consider that we are just taking, so we can consider it like this, that we have total 15 toss, and whenever we are getting an head, we are repeating it. Okay, so we have 15 tosses, and suppose at the fourth toss we are getting an head, we are repeating it, and if at the seventh suppose we are getting an head, we are again repeating it. But if in the repeat we are getting toss, we are getting head, we are not repeating. But if in first attempt we are getting any head, we are repeating. So in that way we can reformulate it. So like yeah, we can also consider like that also, like we will do it at the end, but like that will be a little bit complicated to imagine. Okay, so yeah, so this is the yeah, so P is the probability of head. Here it is given that the probability of head is 0.4 and probability of two consecutive head is P square, because you know, suppose what is the probability of first toss being head? 0.4. What is the probability of second one is head? This is also 0.4. But what is the probability of both of them are head? Because second one will not perform if first one is tails, right? So for both of them, like chances of both happening head is 0.4 into 0.4, like that is like P square. P is 0.4. Okay, so here like P of x given R. So what is the x here is like a number of heads in the second chance. Okay, and x are equal to in choice x, in choice are actually here. So here it means like okay, so I'll explain a little bit slowly here. So this is actually a P is chances of P is the probability of getting head, and 1 minus P square is the chances of getting head, and 1 minus P square is chances of getting not getting head. Okay, like P means like chances of getting both of the head, because for getting head in the second round we need to get head in the first round, right? And so P square is the probability of that, and if it is like first one is tail, that also comes under this. If first one is head, second one is tail, that also comes under this. Okay, so this is the like a formula that forget the two, forget the two or anything here. The formula is that P into R and 1 minus P into n minus R. Okay, in combination R. So this is not x, this is R. This is a typo here. NCR and P P power R and 1 minus P power n minus R. Okay, so in this case instead of P we have P square. Okay, so this is like P square power R. So this is kind of PR. Okay, then 1 minus P instead of P we have 1 minus P square here, and whole power we have like n minus R. Okay, So this is actually standard formula. So because consider this, in how many combination, in how many combination out of n coins, out of suppose 15 coins, in how many combination 5 heads can, 5 consecutive heads can appear, right? So that is why we are taking the combination here, and then we are like taking the probability. So in this case, like we are just substituting n and r with 5. So here it will be like r. So n is 15, r is 5, and 0.4, and here 2r, 2 into r here is 5. So 2 into 5 is equal to 10. 1 minus 0.4 square in power 10. So if we simplify this, the output comes to be like 0.0055. So again, this is little bit tricky due to kind of a second round thing. But if you think this as a sequence of 15 tosses only, with the second toss only appearing if first toss is head, then you can think of it in a very simple way. Okay. So it is actually a little bit difficult to follow from the video. So maybe I'll actually prepare a kind of a document, and I'll try to find some good resource for that. And if it is like if it is not clear, then maybe we can clarify it in the next week session. And also, like there are 2 sessions. I think there is one session tomorrow also from some other TA. So I'll also encourage you to visit those also. Yeah, there are one session. I think there is no, this is not same. Okay, I don't know what they will cover. Okay, so I'm checking the schedule of the sessions. So this is like Sunday we have 7 to 9, and Tuesday you have 6 to 8. Okay, so yeah, they might solve same problems, they might solve different problem also. So that is like not really certain. Okay, yeah, the question doesn't mention anyhow that all heads are consecutive. No, they don't have to be consecutive. Okay, so basically consider like this: you are taking a okay, in first round you have 15 tosses, and you will toss in the second round only if there is head in the first toss. Okay, so suppose you are tossing a coin in first toss there is tail. Okay, so for that specific toss you will not toss it again in the second attempt. Okay, suppose in the second toss you got a head, then for that toss you will toss again in the second round. So basically what is happening is that for the second like getting head in the second attempt, for like tossing itself in the second attempt, you have to get a toss like you have to get a head in the first round. So that is why like it is kind of getting a dependency. So that is why like we can imagine it as a consecutive. I hope it is clear now. So like yeah, they are not really don't have to be consecutive. Okay, video recording I am recording, so I hope by tonight I will be able to post it in the YouTube. I think I'll provide a link in the discussion forum. Yeah, thank you. Yeah, you can get those questions in main exam also. So because you know these are not really so I will show you the questions here. These questions were from practice assignment, okay, but these questions and this question was from Bias-variance, and these are from probability only, and those were from assignment. Okay, and anything that can come in assignment can come in the exam. Okay. I don't really know if you can take calculator. I think you can take calculator. Okay, I'll check it once and get back to you. So I think you can. Okay, so I think calculator is not allowed, but one thing, like there will be a on-screen calculator. Okay, like on the exam portal, wherever you are answering and selecting the questions, there will be an option for calculator, so you can use that calculator. Okay. Okay, yeah, you will get the PPT. I'll send that in the group, discussion forum only. Sir was led to join place question solution discussion. Yeah, I'll share the share the recording as well as question and solutions PowerPoint in the discussion forum. Okay. Okay, Telegram group, it is not will not, because we have a discussion forum. So I'll send the link to of the discussion forum. You can join that and discuss there. Okay. Yeah. Yeah, this is the link to the discussion forum. You can ask your questions there. Yeah, we'll send a PPT to the group, this group. If possible, please extend the week to assignment deadline. Okay, week to assignment deadline is not really up to me. Okay, so I wish I could, but I really can't extend. So maybe, is there any contact person for that? I'll check. Week to assignment deadline is on 7th, and okay. You still have 10 days, 7 to 8 days, I think. I don't know if there is some contact person for this. I'm checking. Please wait some second. But generally, this is not really NPTEL doesn't really extend deadlines like that. So yeah. So I think there is some a contact person whom you can contact and ask directly about extending that, but it is a little bit less likely to get approved for a delayed deadline. Okay, can you please provide some resources for probability? Okay, I'll do what? I'll make a list of things that I will do in the discussion forum. Okay, first thing is that share resource about loss estimation. Then we'll share the video and slides. Then we have to provide some resources for probability. Okay, I will try to find something. Okay, I'll send it in the discussion forum. Resource for probability. But I think the lectures in the week 0 are quite good. So you can do one thing. You can go through the lectures and search those topics if there are any resources. So suppose I'm going here, so you can see The topics are like probability basics and linear algebra. So probability basics, you can do one thing. There is a good book, but I forgot the name. So yeah, you can use this one, First Course in Probability by Ross, and another thing, there is a book, recommended book, right, for this course. I think we have mentioned it in the, yeah. So you can see these two are the books. So Elements of Statistical Learning. So this one is freely available online, okay. And in this book, they have mentioned like much about probability. So you can refer to this book also. Okay, this is available online freely. If some book is like publicly available, then we can share, but maybe I'll just share the name and you can find some resources of that. I would actually recommend to focus on this book, and probability we have some books actually. I think like there will be some lectures on probability in NPTEL also, so you can also refer to that probability. Yeah, yeah. Yeah, these two are the links. So I think here the videos are not really available, but here you can see videos are available, so you can watch every videos there. So you can refer to this, okay. How much linear algebra need for ML IFRS? Okay. Yeah. So yeah, you need little bit of linear algebra to understand ML, but you can also learn it on the fly. So maybe it is not like without. There is actually a book for linear algebra. So that is done in very easy way, you can say. I will just find the book, and also you have the lectures for linear algebra. So yeah, Gilbert's time. Okay, so you can follow this book. And also like you can follow lectures by the same faculty. can follow this one. So if you follow the lectures, then lectures are like really good. So I think if you follow few lectures, then you will be able to understand it properly. Yeah, I will share the PPT in the discussion forum. That would only. So if anybody else has any questions, then feel free to ask. Yeah, I'll share the PPT in the discussion forum by today. Like I'll send a link to the PPT, not the PPT. Yeah. Actually, let me share it right now, but then I'll also share in the that one later. So your assignment submission deadline is, I think, second. Yeah. Yeah. So assignment 1 and 2 both submission deadline is 7th. Okay. So keep that in mind, and try to attempt a practice assignment also here, because even though you will not get grades for that, but this is really good for practicing. You know, some of the questions are common, right? This one we did today. So practice assignment you can do. Books, yeah, another thing, you can find the books here. So not really the books, but it is the kind of, I can say, it is kind of transcript of the lectures. So you can find that here, and yeah. So here you can find everything from the entire course. Yeah. Okay. wait for some time for any more questions, then we'll end the session. Yeah, green is the answer and red is the wrong. Okay. I will also share the video also with you, so you can hear it later. So I'll share the video link in the discussion forum, so you can watch the watch it from YouTube without audio issues. And also there are sessions on Sunday also. So if you want, you can join Sunday session. There is another session Tuesday also, so we can join those also. Okay, welcome. Welcome. You're welcome. Okay, linear regression. Okay, yeah, I'll send the resource to you. Okay, because on the fly it is difficult to come up with some example. So and also, yeah, linear regression is a little bit can be difficult to calculate, because to update the beta parameters. So yeah, I'll send some resource. Okay. And if it is not clear, we can discuss it in the next session, but I think it will be clear. I'll share some good resources. So basically in linear regression, suppose the basic idea is that you are you have some data and you are trying to find for a new data you are trying to find some value, given you have some value, and in linear regression you have one weight and you don't have any in linear you have a bias term like a beta term and one say weight term. So that's it. But yeah, and updating the finding the bias term and finding the weight term is the challenge. So okay, yeah, assignment question I can't really discuss, so because you have to do that on your own. Okay, this is a KNN. Okay, so yeah, so in that case you have to find very similar KNN means see, in that case you have to find what is the point now, and what are the most least distance point. So suppose you are at 0.00, then maybe 0.05 is more near to 1.5 like that. So you have to find nearest 3 point and you have to take average. Suppose consider that you have a let's consider not coordinate, just consider one dimensional example. Suppose you have a height in centimeter and you have a weight in centimeter, okay, weight in kgs. So suppose your height is 170, then there are many data that someone's height is 169 and weight is say 65, 171 and 72, and again there is another 171 which is say 65, okay, and then your is 170. So again there are other data also like 180, 160, but whenever you are using KNN based thing, so your height is 170, so you will take which of the data are nearest. So you find that 169 is nearest and 171 is nearest, so you take average of them. So that is kind of your that is prediction for your weight, that kind of thing. Yeah. Okay, so I'll end the session now. So thank you for joining, and solve the assignments and try to submit in time. Thank you very much.